This lesson is called Remainder and Factor Theorems. Basically, like I said, if you know how to do synthetic division, you will be all right. So to start that, with that in mind, I got two questions for you. Okay, I want you to do this top one here, the negative 3x squared plus 5x plus 4 divided by x minus 3. I want you to do that with synthetic division. Okay, and down here in the second half, I have negative 3x squared plus 5x plus 4. I want you to find f of 3. All right, which is a good review from 5.3. Okay, so up here I want you to do synthetic division of this polynomial. Down here I want you to plug in 3 and evaluate. All right, go ahead. Agreed? Negative 3, negative 4, negative 8. Right? So negative 3x minus 4. How do I handle that remainder? Minus 8. Make that look a little better. Minus 8 over x minus 3. A little big, but that's okay. Alright, good. Now when you plug 3 in, at negative 3 times 3 squared plus 5 times 3 plus 4. Alright, is that up good? What's 3 squared? 9. So negative 3 times 9 plus 5 times 3 plus 4. 9 times negative 3 gives you 7. 5 times 3 gives you 15 plus 4. So negative 27 plus 15 plus 4 gives you negative 8. Coincidence? Actually, no. Not even slightly. That's actually how it's going to happen all the time. Okay, so now here's where you have to be careful. Okay, this one is the weird one. This is the weird duck. Okay, what you can do. What this shows is this. Okay, now whenever you do synthetic division, the way I've taught you to do synthetic division, you've taken the binomial and done what with the sign? You've flipped it, okay? So we were given up top x minus 3. We flipped it to positive 3. All right? You made it positive 3, we went through it, we get synthetic division, we get negative 8. Then we, at the bottom, took what and plugged it in? Took positive 3 and plugged it in. And when we did that, we got negative 8. That's going to happen, okay? This is called the remainder theorem. All right, I should have a nice, pretty slide about it. Yeah, there it is, okay? This is called the remainder theorem. The application of the remainder theorem, if you look down at the bottom text, is there highlighted in yellow. It's called synthetic substitution. Write that down. Synthetic substitution. Okay, make that like a title section of your notes. All right, that's where you're going to apply the remainder theorem. Basically what the remainder theorem says is if you take that number and plug it in, you take that number, do a synthetic division with your polynomial, you're going to get the same results. Okay, as your remainder. The number you get out of it compared to the remainder at the end are the same thing. Always. The important part here is you don't switch the sign. This is the only one where you don't switch the sign. Later on, in like 10 minutes, we're going to do something different where we still switch the sign. So now you're talking about different rules within synthetic division. Okay? Not just switching the sign and putting in the zeros and bringing them down and that, and you shouldn't be good at all that stuff now. Now you got to know when to switch, when to not, and what my answer is supposed to be. Okay, which seems like a lot, and it is. All right, but this is a great way, a great application for whenever I'm wanting you to evaluate, like, say I gave you like x to the 5th minus 4x to the 4th plus 3x to the 3rd minus 2x squared plus Xavier wake up plus 2x minus 5. And now I want you to find f of 3. Or negative, let's go negative 3. The way you used to do it, you had to take that negative 3, plug it into all those x's, take it to all them powers, multiply by all them coefficients, and add that all up. 4 steps. Me, I run it through a synthetic division one time, I circle my remainder, and I'm done. If you want to race, we can race, and I'll make my point to say I'm faster. Or this way is faster. Okay? Alright, questions? Okay, so if f of x equals 3x to the 4th minus 3x cubed plus 5x plus 2, find f of 4. Okay, before you rush in, remember, you guys know the old saying, fools rush in? You ever heard that before? Yeah? Okay, before you rush in, check your polynomial. What's missing? There's no x to the 2nd, so you got to put it in. 0x to the 2nd. That still holds true. Okay, so 4th cubed squared to the 1st constant. And the key here is you do what with 4? You leave it alone. Okay, you leave 4 alone. But then you run through your synthetic division. So you bring down 3. You do 3 times 4 to give you what? 12. 12 minus 2 gives you 10. You do 10 times 4 to give you 40. You do 40 plus 0 to give you 40. You do 40 times 4 to give you 160. Add it to 5, you get 165. Times by 4, it gives you, I believe, 660. Is that right? Anybody check my math? I want to say it's 660. Add it to 2, you get 662 if I could write it as 2 instead of a 0. What am I looking for then? What's my answer? For this type of problem, it's what? If I want to find what f of 4 is, my answer is going to be a... No. Think about what we just did the first time. We plugged it in, we got negative 8. We did synthetic division, or what was negative 8? Okay, but then what are we trying to find here? We're trying to find what f of 4 is. So now apply it. What's the answer? It's a different style. What? 662. That's all you want. All right. That's the difficulty to this lesson. It's not doing synthetic division. You should know how to do that by now. It's what changes. It's what's different. Okay. Do f of negative 1. Do the bottom one. Okay. Fools rush in. Remember that. So remember, if you're doing f of something, you don't change the sign. Bless you. Okay, so 4, you don't have a 4th power, so you put in a 0. 2 goes with the cube, 1 with squared. You don't have a single power, so you put in another 0. Okay, minus 1. Okay, bring down that first 4. Times it by negative 1, you get negative 4. Add it with 0, you get negative 4. Times it by negative 1, you get 4. Add it with 2, you get 6. Multiply it with negative 1, you get negative 6. Add it with 1, you get negative 5. Negative 5 times negative 1 is positive 5. Add it with 0, you get 5. Times it by negative 1, you get negative 5. Add it with negative 1, you get negative 6. And that is your answer. Alright, so now we're going to switch gears. We're going to do what's called the factor theorem. Now, this is a little, I don't want to say complicated, because it's really not. It's pretty much the same. It kind of goes back to the old way, alright? It's the remainder theorem is the weird one, okay, the one we just finished. That's the odd one, that's the different one. So, I'm not saying, completely ignore it, but just know that's the one where you don't switch the sign. Factor theorem is very, very similar to 5-2's questions, okay, where I just said do synthetic division, like you did at the beginning, okay? So I'm going to show you a problem. I want you to do that one, okay? Synthetic divide, 2x cubed minus 3x squared minus 17x plus 30 divided by x plus 3. Good. Okay, when you run it through and you do it all, those should be your numbers. You should get 2x squared minus 9x plus 10. Okay? Now, here's what I'm going to equivalent this to. Compare this to. That's what I'm trying to say. Compare to. What's 12 divided by 2? 6. Okay, that's not a hard question. All right. If 12 divided by 2 is 6, what does that make 2? What does that make 2's relationship with 12? Nope. 14's even too. Okay. If 12 divided by 2, or let's put it like this, it's easy now. If 12 divides 2, what kind of relationship does 12 have with 2? It's a what? Fill in the blank. It makes it a factor. Why is it a factor? Because it divides it evenly. Okay? Just how like 3 divides into 9 or 18 or 27. They're all factors of each other. Okay? Remember? Everybody good? Okay? Now, that's with the numbers. You learned that in like 8th grade. You're in 11th grade now. So now we're up in the ante. Now we're going to talk about polynomial and their factors. See how you get 0 as a remainder? When you get a remainder of 0, what does that usually mean? It divides it, like when we did 12 and 2, we got 6. So we didn't get 6 in the third, or 6 in the fourth. We got 6, remainder 0. That means that 2 divides 12 what? 12 divides 2, starts with an E. Evenly. Divides it evenly. Which therefore, here we go, makes it a factor. Okay? It's all connected. Now, x plus 3 up on your green screen divided 2x cubed minus 3x squared minus 17x plus 30. Fill in the blank. You got a remainder of 0, which means it divided it evenly. Which means x plus 3 is a what of 2x cubed minus 3x squared minus 17x plus 30? A factor. Good. Okay? Now, you're probably sitting there like, all right, Mormon, whatever, who cares? Here's the cool part. Now you're left with that 2x squared minus 9x plus 10. See that? Okay. Guess what it does? No, it is a polynomial. It factors! It factors into 2x minus 5x minus 2. So now the quote-unquote cool part is you can turn a big, long polynomial, like we got up here, the 2x cubed minus 3x squared minus 17x plus 30, into its prime factors when you are given one of them. Here's one of them. Here's the other two. Everybody see that? Don't worry about it. This is me. You're going to do a couple where you can factor them, okay? All right. This guy up here has a special name. This guy is called your depressed polynomial. All right, this 2x squared minus 9x plus 10. It's called a depressed polynomial. What that means is it's the result, it's the answer of dividing a polynomial by one of its binomial factors. Okay? So whenever you divide a polynomial by its binomial factor, you get a remainder of 0. Every single time you should get a remainder of 0. You also know that it's a factor of the original polynomial. If that's the case, then you can turn around and factor the steps. So here's where this differs, okay? From 5.2's lessons where I said here, synthetic divide. Okay? You still switch the sign, you still write them out, you still put in zeros for what's missing. Whenever you divide, you will get a remainder of 0. You rewrite the new polynomial. All of that is old. Everything from this line up, old stuff. New stuff, this guy here, you factor it. I'm adding on one step. Okay? Determine whether x minus 5 is a factor of x cubed minus 7x squared plus 7x plus 15. Then, find the other factors of the polynomial. Your step 1 is to do the synthetic division, okay? So you have an x minus 5 right here, which means you need what in your box? 5. Remember, these are switching signs still, okay? You go to your polynomial, you got 1, negative 7, 7, and 15. You run through your synthetic divisions, you bring your 1 down. You times your 1 by 5, you get 5. You add it with negative 7, you get negative 2. You times negative 2 by 5, you get negative 10. You add it with 7, you get negative 3. You times it by 5, you get negative 15. You add it with positive 15, you get 0. For this to work, this remainder has to be 0.
So it's not 0, it's just...
It will be a 0. Okay? I am not giving you ones that don't work. Alright, so if you don't get a 0 in this synthetic division, you messed up. Okay? Make sense? But you do. Well, that's good. So now you take, just like 5-2, just like earlier, you take the coefficients, you rewrite your brand new polynomial, which is going to be what? X to the second minus 2x minus 3. That used to be your answer. Now you go one step more, and that one step is you factor it. Okay? So what type of polynomial is that? Starts with a T. A trinomial. And when you factor trinomials, you look at two different numbers. One's called a if you factor a trinomial, you got to look at two different numbers. One is your no. One's your multiplied number. The other one is your add number. Your multiplied number in this case is nope. Negative 3. Your add number in this case is negative 2. So to do these, you need two numbers that multiplies to negative 3, adds to negative 2. And those two numbers are negative 3, positive 1. Yeah. In a minute. Well, here, I'm going to do it. Okay, so you get 2 in the box. You got 1, negative 7. 4 and 12. Bring the 1 down. 1 times 2 gives you 2. You add 2 with negative 7, you get negative 5. Okay, signs are important here. Negative 5 times 2 gives you or negative, I don't know why I put negative 8, negative 10, there you go. 4 minus 10 gives you negative 6. Negative 6 times 2 gives you negative 12 to get 0, okay, which is a good thing. So you have x squared minus 5x minus 6, and then you factored that. So x minus 3, nope, false, hold up. X minus 6, x plus 1. Switch to negative 2. Which gives you the depressed polynomial of 4x to the third minus 12x squared minus 3x plus 9, right? Grouping. So what's the first group? What's the second group? Okay. GCF out of the first group is going to be what? 4 what? 4x is second, good. Okay, which leaves you with what? X minus 3. You need that second group to be an x minus 3, so what do you factor out of there? A negative 3, good. X minus 3. You write the x minus 3's together. Put your outsides together. 4 x squared minus 3, and that's your answer. That's what I'm talking about, okay? That can be whatever. You have to know how to when to factor and how to factor what. All right, because all the directions are going to say is that. Find the other factors. However you go about doing that is what you need to know how to do. If it's got 4 terms, you group it. 3 terms, you look for a multiply number and add number. 2 terms, sum or difference of cubes. Those are your main ones. Okay? That's all stuff you should know how to do within a single problem like this. Okay? That's not old news. It's page 355, 8 through 14 even, 17 through 23 odds.